All right. Hello, everybody. My name is Yelena. I'm one of the graduate teaching assistants. And okay, so the purpose of today's meeting is to help you get started with R and R Studio. So here it is. This is an agenda. Guys, if you're not speaking, please be kindly mute yourself. Okay, thank you. Here is an agenda for today. We're going to discuss what's R and R Studio. We're going to talk about the R Studio environmental interface, how to save all the commands in the R script, and I'll show you how to use variables, how to read data from the CSV, and then we're going to talk about the data frames, data visualization, and I'm going to give you some resources, okay? So, for the purpose of today's demo, we're going to be using this data set. It's called human resource data. That tracks employee satisfaction level, a number of years since last performance evaluation, number of projects the person was assigned to, and then the average monthly hours work, time spent in a company, well, etc. And the idea is, if I was going to analyze the data set further, I would probably be interested to see if the employee left or stayed in the company, right? So here are the variables, and this is how the data looks like in a CSV file. We're gonna use it later today. But before we do that, what is R and what are its advantages? R is statistical language, basically. The plus side and the good news, you don't need to pay for it. And it's an open source, so it means that you can create your own functions, you can create your own packages, add to what's already in there. Then R has excellent data visualization capabilities and some of the advanced statistical methods. You may save commands in a script to reproduce the results, and I'll show you how to do that. There is excellent documentation. R is evolving, so as we speak, new packages get developed and updated. It works well in an academic environment, right? There is more than one way to produce the same results, and R can be used with databases that support parallel processing. But of course, there are some drawbacks. If you look at the R itself, there is no graphical user interface, like you've seen in earlier courses, perhaps Cognos Analytics or Watson Analytics, whatever used in DataSix 10, right? You had nice graphical interface. Here, it's not. You need to study, it takes you some effort to learn. You need to learn how to use the help pages. Then here, that's where a lot of errors come from. R is case sensitive, okay? So Yelena in all uppercase, it's not the same as Yelena in all lowercase, right? It might not solve all your problems. Then you cannot integrate it with some of the web applications because it does not have a strong security implementation. And if you look performance-wise, it's lower than Python and Java, and it uses more memory for processing, okay? So for your class, for this class, what you need to do is you have to install the latest R version, right? So you have a web page for the Windows and for the Mac. And the latest R version is version 4. So pay attention. If any of you are repeating the class for any reason, you have to install the latest version, R version 4, all right? Because some of the code that works, right, that worked before might not work as well this time, okay? So there are some differences between version 3.63 and 4. This is a new version that we're gonna use right now. And you also need to install, it looks like this. This is a RStudio, and I'm gonna talk to you what RStudio is, okay? So this is an environment that sits on top of R. It has a little bit of graphical interface, but not as much. There is no such a thing as drag and drop. And you need to write the code because all work you do has to be reproducible, right? So there we go. So what's an RStudio? It's an integrated environment, right? So it supports it allows executing code, but the plus side is that you can do the syntax highlighting, right? You can preview environmental variables. Also, I don't recommend relying heavily on environmental tab. It's in there, it's there for you. You can see the comments history, and this is very important here. You may use R without RStudio, but you cannot use RStudio without installing R. And I forgot to mention that in order to install both of these, RStudio and R, you must have local admin rights on your PC. Or at least if you're prompted for the admin password, you need to know what that password is, right? And we're gonna go back to the hands-on part shortly because I like to actually do it, right? So here is my RStudio. This is what it's gonna look like when you install it. So you have this window in here, right? When you install, this is called the console window. This is a window where you may type the commands, but beware, anything that you type here is not going to be saved in a script, right? We want our work to be reproducible, so I'll show you what we need to do shortly. Then all your output, all your error messages, all your warnings are going to display in the console window, right? Here, at the top right, you see this window, it's an environment. This shows you what you currently have, all variables that you currently have loaded in memory. And at the moment, I don't have anything because I just loaded the application, right? I have not done anything yet. History is the history of commands. So for right now, I'm gonna clear it all, right? Because I was doing something earlier. I may have been doing something earlier, so it was sitting in the history. Well, when you install this, there'll be nothing in the history. Oops, I'm not gonna save this. Now, here, don't worry about connection. This is if you were going to work with a database, perhaps. Okay, now, let's look at this part here. Files are the files that are available for you in a working directory, and I'll explain to you what the working directory is. It's a folder where R is going to look by default. Whenever you're trying to save a file or whenever you're trying to load a file, our working directory is a folder where R will attempt to look at by default. Packages. All code in R is organized into packages. Package is nothing but the collection of the functions, collection of the variables. There are some data sets, there could be some help pages, etc. This system library, those are the packages that are pre-installed. As an example, in your first homework assignment, you're using the iris dataset. Iris dataset is located in the datasets package, okay? So some datasets, some help pages, this is pre-installed. This is what system library is. User library are the packages that you are going to install. They're from Crane repository. And your first package is going to be called a rules. And you're going to be using it for the exercise 2, right? And you're also going to be using it for exercise 3. So this package is going to be used for something called binning and for the a priori rules, which is exercise 3. Right, so this is going to be a first package, and I'm going to show you, I'm going to spell that out, what I'm talking about. But earlier, I mentioned that all work needs to be reproducible, right? So this is what you're going to do. You're going to do file, new file, and then you're going to select R script. And this is how you're going to do your homework assignment. You're going to be typing your code here, right? Like for example, I want to see what version I'm using, right? R version, and notice that as I type, R is helping me, right? It's a type of head feature where I type and it's gonna tell me probably a set of commands, right, to choose from. See this is R version, right? And if I wanted to save this, I could just go ahead and hit save and then specify what I wanted to save and save it in my folder, right? I could do that. But for the purpose of today's demonstration, what I did for you is I wrote a script. In order to open the files that I wrote, I can go file, open file, and then file my file, right? But what's nice about it is this. Look, if I go to recent files, it's gonna show me the files that I recently had opened. So see this is the files that I recently had opened. After this session, you're going to have a copy of this file. So you will be able to attempt to reproduce what I'm showing you today, right? The demo of today's lecture is reproducible because I'm gonna give you this code. Now let's look at this. What is this? This is hashtag it means that everything that follows it is a comment. Comment is a non-executable part of the code. And you have it's just basically a way to document the code. So that way, if I'm giving you the code, you'll be able to see what I was doing in here. So this is a part one, are environmental variables, right? Environmental variables, that's what we're gonna look at right now. To run this code, I'm gonna run one command at a time. So I put my cursor in here, and I'm gonna run this r.version, right? What this command does, it returns me the current version that is installed, right? Which is version 4. And you're asked to do it in your assignment. Well, the reason is because we want to make sure that you have installed the correct version. And now if I look at the history, see this, it wrote down the commands that I wrote. And you can actually rerun the commands from the history. You would click here, and then you will click on the to console. And that would repeat command in the history, okay? In R, as I mentioned, there is more than one way to accomplish the same thing. So for example, I can do R version, but also, this is also correct. You can type version. In your assignment, this either r.version or version, this is correct. Session info is gonna give me more. It's gonna give some information about those are the packages that are in memory. Remember, this is a system library, and the stats, graphics, etc. These are in memory. Then here, basically, you may get some information on a system, which is the operating system that I'm using, and this is the version, right? And this is the date when this version was released in end of April. System time is gonna show me the current time. ls, at the moment, it's not gonna return anything because this shows me the object that I have right now in the environment. And as you see, I don't have anything at the moment. Object is gonna do the same, right? Those two commands are the same. Data is gonna list me the data set that I have available. Here it is. See this? And in your assignment, you're using iris data for this week, right? So it's in here. This iris data set is it's coming from the data sets package. Okay, so this is pre-installed with R. All right, you can also use this R as a calculator. For instance, 5 plus 9, it's going to output 14. But notice that, what did I see in here? I see 1 in brackets. It's because everything in R is a vector. So here, it means that on this row, I output a vector and I see the first element, right? The first number that is in this row is the first element of a vector. For those of you who used Python before, the indexing in Python, the first element is in position 0, but in R, the first element is in position 1. This is important. First element is in position 1. Now, I can also do this. This will just show me, welcome to data mining. It just shows me the string. It's just nothing but print text. Now, here my environment is still empty. Even though I added a couple numbers, I did not create any variables. I did not assign anything. So here is an assignment operator, right? It's less than sign and then the minus sign, right? So here I want to create my variable x and I'm going to assign number 3 to it. So here it is. It's now showing up in the environment. But to print it, I can type print command or I can just type the variable name. It's a shortcut. Now here you may nest one command inside the other. So here, this is little circuit. What I'm going to do here, I'm going to create variable y. I'm going to assign 5 to it, and then I'm going to print it. See, then I'm going to output. I'm doing two things in the same command, right? Now, if I wanted to remove something from my global environment, I could do this. See, this broom will remove everything. I could also do this. See, this is a grid view. I can click here, select this variable, and click on broom, right? I could do that. Let's go back to the list view. I could do that, but the problem is I want all work to be reproducible, right? Perhaps at some point in my program execution, I no longer need this, right? And I want to clear up the memory. So what I do is I can run rm command. Rm takes input parameter x, right? X is a variable name. and it will remove X from the environment. And then in order to remove all the variables, all objects from the environment, you're going to do this. See this? So ls command is going to list all variables that are in the environment, right? So I'm taking here the output of ls command and I pass it to rm command. See this? So this will clear up everything, all variables I have in this environment. Now options, it's going to show me the options that I have, right? So for example, I want to see the width of the window. Then if I have a very long error message, I want to see how many first characters it will show, well, etc. A lot of this you don't even need to worry about for this class, but you just know that you have it. Now, a lot of people ask me how to clear this screen. To clear the screen is Control L, or you can hit on this broom in here, or this is a command. This is how you do it programmatically, okay? Now, def off, that would be used to clear the plots. At the moment, it won't work because I have not created any visualizations yet, right? So it's not gonna work at the moment, but I gave it to you just because that way you have it. History 5 is going to show me the last 5 commands in the history. Oops, run, history. Okay, so here it is. It's going to try to show me the last 5 commands that I ran. Now, I mentioned that everything in R is a vector. To create a vector of elements, we can use combine command, which is C, right? C stands for combine. And in here, I'm going to be combining the values 1, 2, 3, 4, 5, right? But here, what I did was it just output, nothing else. If I looked at the environment, I'm empty because I didn't assign it to anything, right? Here, what I'll do is I create variable X, and I'm going to assign elements 1 through 5, but I want to save myself some time on typing. So if I put a column like this, it means it's going to take 1 through 5, right? It's going to take 1 through 5. Then I can see what my X is, right? It's elements 1, 2, 3, 4, 5. Alternatively, I can only display the third element. So I put the element index in the brackets. It's going to show me the third element, right? But number 1 here means that my output, right, is a vector. And this is the first element. At some point, we're going to get to the point where the vector won't fit in one line, and you'll see the numbers that you see in the brackets. It's an element, it's an index of an element that appears first on the line, all right? So now here, class and type of, those 2 commands you can use to show the data type. In this case, X data type is an integer. The str command is going to show the structure. Well, in this case, it's just right? Just the vector 1, 2, 3, 4, 5. And here it shows that it has 5 elements. Now here, suppose that I want to create a list of elements 1 through 10, but I want to omit 6 and 7. So I can go like this, right? See, I'm using C command, which is a combine command, and I'm combining 1 through 5 and 8 through 10. So I can do that, right? And then I can output Y. Well, I know that I have environmental window, but still you don't want to rely on it, right? Because sometimes, what if you have to use a script, right? The shell script or something, or the terminal, if you have to use R directly, if you don't have these windows, you need to know how to do it. Now here, I want to output the elements 3 to 6. So I want to take a Y, right? And I want to only show and sort through 6 elements. This is how you do it. Well, it might sound simple at the moment, but we'll get to it. It's going to be harder. It's going to be used as part of the larger commands. And then again, class Y is going to show the data type. str is going to show the structure. Now what I can do is I can multiply it by 2. If I do that, every element of Y is going to be multiplied by 2. Right? So now sometimes I can create a sequence. Well, and suppose like I want to create a sequence of 10 elements starting from 1, I can use the sequence command, right? Instead of doing 1 through 10, I can do the sequence. And the reason is because sometimes I want to specify the step, right? For instance, I want to start at number 2 to number 10, right? But here, I want to go from 2 to 10, but I want to increment by 2. So I want it to look like 2, 4, 6, 8, 10, right? So that's how you do it. And then if you look here, of course, you're going to see it, right? It's M, 2, 4, 6, 8, 10. But again, I suggest that you write all the code, right? One benefit of R is that it has an excellent help system. For example, suppose that I want to do my bar plot, but I have no idea how it works. Very easy to display the help page. I can do the question mark and just put the command that I want to look up. And as soon as I do it over here in the help tab, I'm going to see the help page. The help page explains the command usage, and it's going to show me the parameters that it takes, right? Okay, then in here, it's an explanation of what each parameter does. And then there are some examples of how it's used, all right? Alternatively, I can type the word help and put in a parameter, in a parenthesis bar plot. That's another way. Or just assume that I don't know the correct spelling. So this command, apropos command, is going to give me the set of commands that contain the word, that contain bar, because I specified bar, right? Then I just know that I'm looking for bar plot, right? And then I'm gonna type this question mark and bar plot. And also you can look at examples, and what this will do is it will search online help manuals for bar plot. So if I click this, it's gonna open up your default browser, and it's gonna open up it gives you the available help pages online, okay? Now what we're gonna do is, for this homework assignment, you use the data set that was pre-installed. But starting from the next assignment, you're gonna upload your own data sets. So how do we do it? Let's talk about how do we do it. First of all, we have to save the file to your C drive or whatever drive you're using, right? C drive. I created a folder on my C drive and I called it data sets, right? But remember that if I try to save the file or upload the file, by default, I'm not looking at the datasets folder, right? By default, I'm looking at the documents folder. So if this one, get WD command, this is gonna display me the current working folder. So this is a documents folder, and this is my computer name, the computer username. Elena stands for the Elena, my childhood nickname, okay? So this is a folder where R is looking by default. But I wanted to be looking at the data sets folder because this is where I saved my file. So this is a command you're gonna run to set the working directory. And take a look at this. If you look at this title bar here, it shows what your current directory is over here. But to get it programmatically, you just run this command, get WD, and it's gonna show you what your current working directory is. Here, list.files, it's gonna show me which files I have in the working directory, okay? Now here, if I'm not sure if the file exists, like for example, I'm trying to read the file and it does not work. Here, file exists command is gonna return true if the file exists, okay? So now you're gonna pay attention to here. What we will do, we have a CSV file, hrdata.csv. And I'm trying to read the data from that file into the object is called the data frame. I want to read the data into data frame, which is our object called HR. Okay, now I want to keep the header as is, right? So if you go back to the slides, see this is a header. I want to keep the header as is, these headings over here. Now, take a look at this. You have some variables here which are categorical, right? The categorical variable is sales, right? In R, categorical variable is called factor. So here, the department, it's going to be a factor because it has a set of specified values, right? We know the values in advance, and the number of values is finite. Like salary, in this case, it's not a numeric, it's a factor because it's low, medium, high, right? Starting from this version, starting from this R version, you need to set as is parameter equals to false. If you don't do it, it's going to read those factor variables as a string. It's going to read those factor variables as a string. So we tried to correct as many places in the classroom as we could, but when you'll be watching the recorded videos, starting from week 3, there are some recorded videos. In order to run the files that are provided and to read data that is provided, you would have to add this parameter, as is equals false. If you don't do it, your factor variables will be read incorrectly. So you have to have this, because if I do this, right, I'm gonna run this now. See this, I read this HR. HR is now the data frame, see this? Over here, I read it correctly because I want the salary to be factor. I don't want it to be the string, right? So this parameter is required in this R version. It was not in the earlier, it would read correctly as expected, but now you have to have this. Now, header equals true, that means that I want to read the header from my file. If I don't include it, sometimes R can give it like A1, A2, but this is not descriptive, right? Yeah, so we have to do this. And this one, it tells me that my file is a comma delimited. Well, of course, by default it's delimited, but we don't want to rely on defaults, all right? So now let's preview. View command is going to show me the data. This is a spreadsheet-like view, okay? See this? You could do the sorting here, you could do the filtering, but remember, any work that you do at the interface level, it's not reproducible. So, you know, if I was going to make a mistake here, right? I'm running the code, I made a mistake. Please take a note that there is no undo button, right? Yes, there is no undo. No, there is no undo. So if perhaps if I deleted part of the data set unintentionally, part of the data frame, there is no way to undo. The only way to undo is to rerun the script, to reproduce the work. I would go back from the top and rerun my script. That's the only way to undo, okay? So that's another reason why your work has to be reproducible, because sometimes if you make a mistake, you cannot just undo. The only way to undo is to rerun the script. Yes, then another thing is that a lot of homework assignments cannot be done in one sitting. So you need to get back to where you were before you stopped, right? So you just rerun the code, right? So you're saving yourself a lot of time. And then also you have to submit the script. So that's another part of it. So now this command here is going to be your friend, because you can display the first 6 data rows of the data frame in a console window. So sometimes you want to see what actually got loaded, right? So this is a head command. Now look at this, it's wrapping. It's because we have many columns, right? It all does not fit on the same row, so it's gonna wrap. But I'm looking at the first 6 rows. 6 is the default. Now here, suppose that I want to see 10, so I want to specify I want to see 10, right? Then tail is going to do the last 6 by default, or I can specify I want last 10, okay? Now, str command is going to show you the structure. Basically, take a look at this. This is a structure, right? But again, imagine I don't have this window, I don't have this environment. If I was running just R, not RStudio, I would have to do this, str, to see the structure. And what it's showing me is that it's showing me the number of observation. So each observation corresponds to the data row in a CSV file. Each variable is a column in a CSV file. And here, those are the numeric, right? Integer, it's basically also numeric, but it's a whole number. And factor, Now, what levels is? Levels are basically the distinct values. And if you see something like this too, it means that the value in the first row is going to be low. The value in the third row is going to be medium. Okay? Now, class is going to show the data type, which should be data frame. And again, is data frame is a way to check if it's a data frame. It's going to return true. Okay, now here, this is several ways to show the variable names. Well, you might be thinking, what is Elena talking about? I can just go in here and I see my variable names, can't I? Or I can just run view command and etc. Well, you need to know how to do that programmatically, because sometimes perhaps you want to write the code that loops through all of the columns, right? And does something for each column. So sometimes you have to create a list that stores the column names, something like that. So there are two ways to do it. You can do names, or you can do the columns. Notice this. I was talking about earlier that R is a vector. See this here, number 1 means that this is the first element in this vector, and this is the fifth element in this vector. See this? This is a vector. What it returns? The list of column names, right? And I can be using this as an input to something else, right? DIM command is going to show me the dimensions, which is number of rows and number of columns. Here, this is how to display the number of rows. I can take the nrow command, or also remember this, DIM, this returns 2, right? 2 elements. If I take the first element in here, it's going to give me the number of rows. The second element, the number of columns. So I can do it this way too. So basically, the reason I'm giving you 2 ways is because you're going to you'll see it differently in the readings, right? You'll see different in the readings. So that's the reason I want you to know both. So here, this is a number of variables and call number of columns, or you can do length, or you can take the second dimensions, or what this is going to do, remember, names returns the list of column names. And I take the length, it's going to return me the number of columns on the columns list, basically. Okay, now summary command shows me the descriptive statistics. You may want to pay attention, because this is going to be, there is a question in your exercise 2. There is a question between str command and the summary. So remember that str, it shows the structure, right? So basically it's showing me which variables I have, and the data types, number of rows, number of variables, etc. The summary command, it's gonna run here. I'm running it for the entire data frame, and I'm gonna show the statistical information rather. So let me run this. Let's see. Remember that we have 2 types of variables, right? So numerical, basically it's continuous. It's gonna show me the minimum, the first quartile, the mean, the median, maximum, and also, and A stands for missing value. It means that I have at least 1 row in the data where last evaluation is missing. Here is the same thing, right? I have a missing values, and we're gonna get to it today also. Salary, this is a categorical variable or factor. For the factors, what I see is that I see the value and the number of data rows that have each value. Here, the department, I have more than 6 departments. So what it's going to show, it's going to show the top 6, right? The dominant 6. And after that, it's going to list the rest of the remaining departments into other category. Okay, so this is what it's doing here. For the categorical, I'm going to see the dominant 6, and everything else is grouped into something called other. All right, this is just the behavior. Now, suppose that I had 200 or 2,000 variables in the data set, and I'm only looking into satisfaction level. So R allows me to display just the summary for the satisfaction level. To do this, you specify the data frame name, then you put the $, and after the $, you put the variable name, right? Or the column name. This is case sensitive, remember that. But the nice feature is that there is a type ahead. So as I type it, it's gonna give me the list of columns to choose from, right? There is a type ahead functionality, which really helps a lot. Anyway, so here, summary, this shows me just for one field, a little bit different layout. Apply command, what it's gonna do, it's similar to summary, but the output is gonna look different. It's gonna run the summary command on every variable in my data set, and it's gonna show like this. Now, take a look at this. This is one difference. I have more than 6 departments. Here, it's gonna show me, it's gonna break down. It's gonna show me the counts for every department, not just the 6 dominant, all of them. See this? So it's different. The idea behind this command is the same, but it's slightly different layout and gives different information. See this here? Yes, I see all departments. Now, you also can see just one statistics. Like, for example, if I want to know only just the minimum satisfaction level, I can just run the minimum. Another thing that you can also do is you can do the range. It's going to give me the minimum and the maximum, right? Range. Standard deviation is not part of the summary command output, but you can run it as it's a standard deviation. You can run the standard deviation for the satisfaction level, just an example. Now here, HR department, it's a categorical variable or factor. I can display unique values. To do that, I can do unique commands, or I can do the level commands, right? And here, this is, I just want to see the higher satisfaction level per department. So this is how you would do it. You use aggregate, then you put HR satisfaction level by department. See this tilde here, it means by, okay? And this is the field I wanted to group it by. And the function is a maximum, and I think it's gonna be 1 because 100% satisfaction is the highest satisfaction in each department. Now we're gonna start taking the subsets. The way the subset works is that you're gonna specify, see here, this HR is a data frame name. In the brackets, first you want to specify the set of rows that you're interested in, and then the set of columns. Like here might be a good example. I'm taking the first 5 rows and the first 3 columns, right? It might be the first example, right, to show. So I got the 5 rows and 3 columns, right? Now, what I'm gonna do here, if the columns are omitted, see this, I have the rows, comma, and nothing after that. If I omit the columns, it's gonna give me all columns, first 5 rows, and all columns. This is what I see, okay? Now, here, what I can do is I can create a new variable from it. I can create new HR, and I'm gonna set it to the first 5 rows, perhaps. See this? It's gonna create a new data frame in here, right? This is what I just did. I'm just showing you what can be done, so that way later we can, you'll know what I'm talking about, right? Here, it's an alternative way to do this. I want to select the first 5 rows, but I want to take the first 6 columns. What this does is that names HR, this is a list of column names. So I can say, okay, I want the first 6, I want the columns that appear on a column, that are the first 6 on the list of column names. Let's say it this way. It's just another way to do it. Here, I want to explicitly list the columns that I want to take. You need to use combine, because combine is going to list. See this, like over here, I want to select column number 1, 4, and 5. So you use combine to create a list, see? So, yeah, but sometimes I don't know the position of the columns that I'm looking at. So I have an option to specify the column name in here. So remember that the column names are going to be case sensitive, right? So I'm taking the first 5 rows and these 2 columns. Now, this might not be a good example to run, but what this will do is it will take all rows, because the rows are omitted, and it's going to pick these 2 columns. But what's gonna happen right now is this. See this? This is this number of rows is omitted because I reached the maximum output size. Do you remember earlier we looked at the option? One of the settings is the maximum output size. So if it reaches certain number of rows, it's gonna cut off. All right. So now what else I could do is, see this HR salary, it's gonna take the salary variable of HR data frame, and it's gonna take the first 4 values of HR. But this is what it's gonna do. Okay, this is the first 4 rows. Now here, when I specify which rows to select, I don't necessarily have to specify the row number. I can select the rows that meet certain conditions. Like for example, here I want to select the rows where salary is medium, and the variables here are omitted. So it means I want everything. I want all columns where my salary is equal medium. And of course, I exceed the output, right, size. Well, what we could also do is I could limit it further. I can say the department is HR and salary is medium. See this? I can combine 2 conditions in here. Well, it's still too large, but that's okay. If I wanted to, I could add more. If I wanted to, I could add more. Now, you might be wondering if it's possible to add a variable. Yes, it is. So let's say we have the time spent in the company, we have in years. Suppose that for something that I'm analyzing, I want to look at how many months an employee spent in the company, and the number of months is going to be time spent in the company times 12. In order to add a variable to the data frame, this is what you do. You put, this is the name of the data frame, this is a $sign, and this is the name of the new variable, and you assign it to this, HR, time spent in the company times 12. Okay, it should work. But how do we know? Oops, let's do, well, I need to undo. Okay, well, you can undo the changes to the code, but you cannot undo the changes to the data. Okay, remember this. So now I'm gonna run this, right? I'm gonna run this command here, but in your assignment, you're gonna ask to verify that commands work successfully. So to verify that the column was added as expected, you can do, perhaps one way to do it is to run a head command, and then you can see if this is the last column here, or you can do names to check the column names, right? But probably I want to preview the first 6 rows because I want to make sure that the number of years, well, the number of months is in fact this times 12. I want to verify. So it's this is what it's meant in your assignment exercise 2, which will be due next week, right? So starting from this semester, the weeks end on Tuesday, which would probably be better for you guys. I'm not sure how it will work, but it will work better, I think. Okay, so now, if I no longer need month spent to delete it, I just set it to null. Deleting it, just setting it to null. That's it. And then I run my head command again, and I see that it's gone. Now, what else I could do is, I could do the sortings. Well, sometimes I want to look at perhaps 10 people with the highest satisfaction level, right? How do I know this? The only way to know it is to sort my data first, right? Sometimes also you sort to identify the duplicates, because the duplicate records would probably be the adjacent records, right? So this is the reason we do the sorting. I hope everybody's taking, well, at least everybody's paying attention, because I have the slides and the notes are on the slides too, but what I'm showing here is important. You'll see why when you start working on exercise 2. But anyway, so here, I'm going to create a new data frame here, and I'm going to call it HR sorted. And here, what I'm doing is I'm taking all variables, but for the rows, I want to sort by the satisfaction level. Right? This is what it's doing. And here, I'm previewing the first 10 rows with the lowest satisfaction. So basically, I'm trying to see at the 10 least satisfied employees. Well, apparently, the values are almost the same. Oh wait, no. See this? I'll have to look at the satisfaction. This is the lowest satisfaction. Well, in my case, the values are the same. But what I could do is I could specify, I could sort by two variables. Like in here, see this? This is the satisfaction, and this is a number of projects. Like for example, see this? These guys here, they have the same satisfaction, but number of projects is different, right? So I can also do this and then preview, right? See this? This is what I did. So then you're gonna be asked to verify, and see this? These are the satisfaction, right? And this is the number of projects. The number is going up. But what I could also do is I could sort descending. So to do that, you put the minus sign. If you put the minus sign here, this will sort the descending by the satisfaction level. Descending. All right. So you just know this. You have different ways to sort it, and I'm gonna give you the script. Now, one thing that you may have noticed is this. You have a variable called left, and the value is either 1 if a person no longer is with the company, or it's a 0 if the person left. So take a look at this. Right now, what we'll do is, actually, for some unknown reason, it's showing as 1. And when you looked at the output, if you run the summary command, right? If you run the summary command, summary on HR, right? See this, and then I put this $, and I'm gonna do left, right? If I run it, watch what it's doing. See this? It's showing me the medium, but why do I see the mean value? Does it mean that 1/5 of the person left the company? Could that happen? No, see, it's not what I want. The person either stayed or left, right? So secretly, this should be a factor variable, right? For some of my analysis, it should be a factor. So what I could do is I can convert it to the factor. Factor will convert it to the factor. So what I do is here, see this is to access this HR, right? Name of my data frame, left is a variable name, factor is a function that takes this as an input. I'm just converting it to the factor. To verify, I just run the summary command, and now it's going to show me the number of people who left, number of people who stayed. I also can run isFactor command, and it should return true. Okay. Now, we're going to look at more functions for the factor variables. I can show the frequency count. Table command is going to show me the frequency count, right? Like this. Also, I can see the proportions, the proportion, right? But one reason we do table command, because it's also used as an input to build the pie chart. And it's going to be used as an input to build the pie chart, table command. Okay, now here, I can also do this. I have two variables, right? Salary and left. So here it's I called it a crosstab, right? See this? I have high, low, medium, and then how many people with each salary level stayed and how many people left, right? This is a crosstab basically. Now what we're gonna look at the missing values, but see, this is something odd. If you remember that last evaluation variable, it has some missing values. Well, we have some rows, we have at least one row that's missing a value. Now what I'm gonna do is I want to calculate the average number of months since last evaluation. I'm gonna run the min command, and let's see. It does not return the output because I have at least one row in the that's missing the values. So some functions don't work. So what I need to do is, this is a trick, na.rm equals true. So here, if I don't want to handle missing values, I can explicitly handle them here. I can exclude them in the calculation. So if some of you, perhaps if you use like Oracle or SQL, something like that, SQL, you remember that when you compute the average on the column, it will ignore null values by default, right? It will just ignore them. Not this. Min command in R does not ignore the missing values. It's going to return NA. It just fails. You have to explicitly specify that you want to ignore missing values. and you do it by na.rm equals true. So now it's gonna work, right? It's gonna work now. Now, earlier, we ran the summary command and to check if the data set has missing values. But what if I'm lazy to look through all of the statistics? I want to know if my data set has at least one value that is missing. So what isNA does, isNA, in general, it will look through all values in the data set and it will return true if the value is missing. So any is going to return true, or it's gonna return this. Look, if at least one value somewhere is missing, it's gonna return true. At least one value. This is an HR, right? It's gonna check if at least one of them. Okay. Sum is gonna return how many values are missing. So here we're gonna get more information, right? Sum two, right? Total 2. But we don't know, remember, we don't know how many values are missing in each column in here, right? It's total for the whole data set. We're not looking at each column at the moment. Now, what you could also do is this. Sum, it's going to tell me how many values are missing in each column, because what I did here, I put the $sign and I put a column name. So we are looking at just the specific columns. So for example, here it's a return just one. Now I want to know which element is missing, which row is missing the value. So here, which, see this, I'm taking this piece right here, it's gonna return this here, it's gonna return the actual row number. It will return the actual row number where the value is missing. So 375 is the row number. Now here I want to display the row that has a missing value. In general, complete cases is going to return false if something is missing. So this is complete cases in general. This complete cases is going to return the rows where the values are not missing, right? If at least one value is missing in a row, it's not going to be returned. Not complete cases, this guy right here, returning all rows that this is going to return false, because it's going to return false for every row that is complete, right? So now what I want to do is, here I want to return, here I want to find out which rows are incomplete, right? So here, if it returned false, it means this row is complete, right? So if not complete cases returns false, it means that this row is complete. But I want to take only complete rows. I want to take a subset of rows that are complete, that are incomplete, sorry, that are incomplete. In here, I'm taking the rows that are incomplete, these two, right? Because, yeah, over here, I'm taking, this is a rows condition. I specify the rows condition incomplete. See this? I want to select the incomplete. If it's incomplete, then it's gonna be true. If it's complete, then it's gonna be false, right? So I want to select the rows where I have something that's incomplete, where I have at least one missing values. And take a look at this. Do you see this row number 375? It's missing last evaluation. See this over here? When I run this command, I wanted to see which row is missing last evaluation, 375. And here it is, my row 375. So this is one way you can do the verifications in your assignment, right? So here I find out which one, and here I output the actual row. See this? Now in here, this is what we did here. Now here I want to check, this is a way to check which columns are missing the value. See this? It's gonna do the sum. So here it means that one value is missing. Average monthly hours, one value is missing. Okay, so there is multiple ways to handle the missing values. Sometimes you want to select the rows only that have a value. One way to do it is this, NA omit. Guys, if you're not speaking, please stay on mute so that way we're going to minimize the echo. Okay, now, so I'm going to select a copy. I'm going to select the create new data frame, and I'm going to assign the rows in a HR without the rows that have a missing value. I want to exclude these two rows that have a missing values, right? So this is what we're gonna do. Guys, do yourself a favor, please also turn off the, right. Not sure what's going on, it's a new Zoom version because by default I have everything turned off. Okay, so yeah, we're gonna create this here, new HR data frame, and I'm gonna select only complete cases. There are two ways to do it, okay? NA omit, that's one way. And this here, what I'm doing is that I'm only taking complete cases and all columns. So just, I want you to keep in mind that there are two ways to do it. And if I ask you to verify, you would probably want to check the number of rows in this, right? You could probably do this, something like this. You're gonna do n row, right? You're gonna run n row command, and you're gonna check the number of rows. Like if I look up here, we have two rows that are missing a value. So I expect to have new HR, I expect to have two rows less than in the original, right? That's what it is. That's how you verify that the command worked as expected, right? Now, what you could do sometimes, you might end up losing data if you just omit the rows missing a value, like perhaps if the data set is too small, perhaps, right? Or sometimes you could, one option is to set the missing values to the column average. So this is how you obtain the column average, right? Remember, we had looked at it earlier. You want to use the min command, and na.rm, you want to set it to true. So that way the calculation ignores the missing values. This is how you get the average. What you need to do in here, you want to pick up the values of the last evaluation where this value is missing. This is how you do it. See this? You're looking at HR evaluation field and you're picking up where it is blank, right? You're looking at the rows where it's blank and you're setting it to the monthly, you're setting it to the column average, sorry. You're setting it to the column average. Sometimes you want to handle it this way. Well, it's just an example. Now here, perhaps I have the business rule where I want to, if the average monthly hours are missing, I want to default it to 200. It's just a business rule. The way you handle it, it depends on your business rule. And now what you do is, well, I can run the summary command for this variable to verify that I no longer have an ace, right? I can do this. Or I can also do this. I can run this command to check which columns have a missing value. Everything is 0, right? I don't have any more missing values. You are asked to verify. How do you know that the missing values are gone, right? This is how you do this. So we talk about missing values, right? Here, I'm going to talk about the packages. So if you go back in here, we talked about in R, all the functions, all of these help pages, etc. They're split into the packages. Some packages are pre-installed, like for what you did in the first homework assignment, you were fine with just pre-installed. But for the next one, you're going to be asked to install the rules library. So this is a repository. And in fact, if you run this command over here, you're going to open the browser. And in here, it's going to list you the packages that you have available. And you take a look, the list is growing. The list is huge and it's growing and it gets updated daily. So, you know, what's important in R is knowing how to read the documentation. It's important because you're not going to know all packages that exist there, but you will know how to use the help system. So now this one is library command is going to return the list of packages that you installed, right? Library is going to list the packages that you have. Oops, I need to go back here. It's showing me here, actually. This is a list of packages that you have installed. It showed me in here. Now, okay, so rules. This is a user library. And this is the system library. User is what I installed. I wanted to mention that if you have an earlier version of R installed in your PC, unfortunately, if you installed any packages before user library, you would need to reinstall them. Well, you would need to update them anyhow, because you always want to use the latest and greatest, right? But you would need to install everything, all packages that you had up here in the user library. You would need to install again, because this upgrade, the upgrade from 3.63 is major. So you would need to reinstall all the user packages if you use the earlier R version on your PC. Okay, so here, this is a list of all installed packages. Okay, that's one way, because sometimes you want to check if the package is installed, and the list is huge, right? So search is going to list the packages that are in memory. Notice that I have a huge list here that are packages that are installed, but the package is not available for use unless it's in memory, right? So here it is. Those are the packages that are right now in memory, like datasets package is a package where the iris data is. Here, will show you the location on your PC where you have the packages installed. In my case, I have two locations, right? This is here program files. This is where the pre-installed packages are. So this is the reason why I told you you need to have admin rights on the computer to install the R, because it puts this application into the program files. And here, this is going to be your user repository, right? If I go in here and I put in this path, see this? What you will see is over here, this is a Windows library, and it's going to put a folder for every package that you install. This is a Win library. I use the older version on this PC, so that's why I have 3.6 folder. You're going to have 4.0 folder, and this is where the packages that you install are going to be sitting in here. And for each package, right, that you install, over here, you see the data that is pre-installed with that package. You have this code, you have other libraries, you have help pages, etc. And some of the packages, they have what they call vignette. So that's basically a PDF file with examples. Like a rules package, it has a nice vignette documentation. You may find it online, or you may also find it in here. See this? In here, this is where you get the pre-installed packages. Well, I'm sorry, the user packages. When you install your very first package, you might be prompted to create, if you want to create this folder. If you're prompted, select yes, okay? If you're prompted. I was not prompted, maybe because I had the older version in there, okay? So our version 4, it's going to create the folder like this, 4.0, and this is where it's going to put your packages. But in case you might be wondering, this is what I had from the past semester, right? This was 3.6, and those are the packages that I installed in the past. But this semester, I would have to do everything from the beginning, of course. I cannot just go back and update. I need to install from the beginning because it's a different library, okay? Now, what we're gonna do in here is this. You're gonna run this command to install the package. I'm not gonna run it because I already have it installed. Library command or require command, these two are gonna put the package in memory. So like right now, I could use what's in there. Now, this is in red, but it's not an arrow. Some messages in R are informative. This message is informative. What it tells me is that in addition to a rules package, it loaded matrix package because I have something in my package, something in the rules that requires using matrix. Something depends on matrix. What this also told me is that my rules package has the function with the same name that is a base package. See this? These two packages have a function with the same name. So if I was going to use a function that is with the same name, I would have to qualify the function name with the package name. That's what I would have to do. Because see, this is just a warning. This message is informative. It tells me that my rules package has these two functions, which are the same as in package base that is already loaded. This is not an error. This is an informative message. It does not say that it's an error. So just keep that in mind as you keep on working on this. What else you have in here? This is how you want to learn about the package. Library, and then you put help, and this is going to show you the help page, right? It's showing you the help page in here. Similarly, you can view the vignette if it's available. In this case, it's available, right? So this is what you would do, and it will open in here in the browser. But do you remember earlier I showed you the location where it's sitting? It's sitting right where the packages are, right? It's in the user install packages folder. So this is basically the examples. This is the examples of how this package can be used. And you probably want to look at some of this when you do the association rules for the week 3, etc. This is your first package that you will use. Okay. Now, let's see. We look at this, and we also going to look at the data visualization. But here, this one is going to update the package. Update packages, this one is going to look for the update. And if there's a latest version, it's going to update. So question update, I'm going to say yes. And it's just going to pick up if I have a latest version. And it's going to check if it is. See this? Okay, I'm going to hit cancel for right now. Okay. So basically what this does is it's going to check the packages. It's going to check if there is a new version. See this? Like, for example, for my rules, this is the version I have, and there is a new version already. It has been 2 days only, and now they have a new version. And I can also do this. This is when I do this, it's gonna show me all packages are up to date, so I don't need to worry about it. Okay? When I click on update here, if anything is not up to date, it's going to tell me. And this is one thing you want to keep on updating because this is evolving. Data visualizations. And what I did here, I spelled it out when you use each. For your assignment, you're explicitly asked to look at the histogram. One thing to note is that starting from this version, the fill color, the default fill color is different. I think before it was white. So well, basically, when you compare when you're running the commands in a walkthrough that is given, your output might look slightly different from what's in a Word file. And the reason is the fill colors, right? Default fill colors change. Things just change if you go from version to version, right? And the same thing to the book. The book does not get rewritten every time the new R version is released, right? And the patches are coming. I'm sure they're going to be the patch in a few weeks, right? From now. They keep on updating it. Okay, so now in your homework assignment, you're asked to look at the help page for the histogram. And you're asked to do it for a reason, because later on, when you run the command to build a histogram, you're encouraged to use the options, right? Like, for example, I can try to change the number of bars, right? I can try to change the color. Border is blue, something like that. And I can change just the fill color to blue, something like that, see? And you may also combine the parameters to do something fancy. Well, even though just using the histogram by itself satisfies the answer to the question, you want to do a little bit more beyond. You want to show professors that you not only ran the command to show the help page, but you actually read what's on that help page, right? So you want to go a little bit beyond and try any of these parameters, right? For example, you can change the title, right? That's another thing you can do, right? So I'll leave it for you to play with this, right? So I change the axis names, and you can change the title. Do something like that in the assignment due tomorrow. Here, bar plot, it works well to show the frequencies, right? So basically what I'm doing, there are two ways to do it. The bar plots take table as an input. I can create a variable called salary, and I can store my table in a variable. This is it, right? And then I can take this as an input. This is one way to do it, right? Or I could just take this as an input directly to this command. I can do that. Or I can split it into steps. It does not matter. Here, what I'm doing is this, I want to sort it. I want to do the sorting. See this? This is sorting by the frequency. Here, I can do it horizontal. Here, I want to do both sorting and horizontal. So basically, what I would do is this. I would probably run the help command for my bar plot, and I see which options are available, right? Pie chart, we use it to show the relative frequency. But here, you need to keep in mind that this could be hard to read when you have more categories, right? When you have more values, a lot of values that we want to look at the frequencies of, right? It becomes hard to read. But in general, you can change the radius, you can change the colors, etc. You can play around. A box plot, this is for numeric variables, right? Box and whiskey plot, this is for numeric. Plot, this is basically more like a generic plot function, right? So if the variable is a categorical, it will do the bar plot. Here I can do the line because salary, right? It's just gonna do it's gonna do the frequencies, and it's gonna do the line because I specify type line. Now here it's not gonna look nice, but well, actually this is good. This still looks good, right? So this one is for two categorical variables. This one is not gonna look nice. This is for the single numeric variable. This looks yuck, I know. But I'm just showing you when you would use each plot. And this is for two numeric, okay? Well, sometimes you would probably look at it when you have less values, so to speak. But I'm just showing you the different types and when you use each, right? Another thing that I may have forgotten to tell you is that we were looking at adding variables, we were looking at removing variables. I may have forgotten to explain why we remove variable. Well, the reason is sometimes the variable could be confidential data like social security number. We don't want to use it for analysis, right? Sometimes it could be ID, unique identifier. You may notice later on that some methods, they do poorly when you have a unique identifier, such as neural networks. They have a poor performance if you have the unique identifier. Another reason would be if you have a skewed variable, or like, let's just give an example. Suppose that I add another column here, I call it state, and everybody is from Maryland, right? It's not worth keeping the state. I can save the computational complexity, right, just by removing it. Or if I have at least like most of the people are missing a value, then what's the point of filling in the missing values, right? I can just get rid of the variable itself sometimes. So there are multiple reasons for removing the variable, right? So basically, now I want to make sure we covered everything. I think we did, but well, usually the way I do is that I just do the hands-on, just go by the script, but then I just look back to the slides because basically slides is notes, right? I was working on the script, I took some notes, and then I'll let you have a copy of those notes. That's how that works. And yes, for the working directory, remember that that's a folder where it's looking by default. You can use the menus to, you can use the options menu to set the working directory, but I'm going to talk against it because you want the work to be reproducible, right? So you want to add this command in your script. You want to add this in your script because when you access the application, when you relaunch the R again, right? You might not remember to go back to options that you need to go back to, right? So always do in the code because it's easier to reproduce the work, right? So basically, this is just basically the summary of what we did. And this is your first package, rules. but I mentioned that there is a bonus, and for the bonus, there is a site called Cognitive Class, and you find buckets of classes in there. Those are free, totally free. You just create an account, and you might be interested in this after these classes, or if you want to learn R more. And this one will give you a little preview. In Data 650, we have one assignment where we use R with databases, so it's possible. And if you're so anxious to learn about it, you can. There is a little course in there. But before you do that, make sure that you get comfortable with R in general, okay? And these are some of the tutorials. Then LinkedIn has a couple groups that you may consider joining. At least I did. And here are some web pages like R documentation, R studio documentation, R and data mining, available packages. Those are something that you could consider just bookmarking. There are a lot of stuff on the web, but I just put it basically as references, so to speak, right? So now let me see if there are questions. Just a quick reminder, in case you may have taken some of the lectures I did before, and I did them in Data 610, you remember that I really like students who ask questions. Remember that, so I don't want you to feel shy. I want everybody to ask questions, and it's an opportunity for you to ask. So to ask, you can type it into a chat or you can unmute yourself, but let me check the chat. Or chat. Let me see if there is anything in here. Nothing is in there. So, but I would like to see you asking questions, because at this point you will have read some of the materials. Hopefully you're almost done with your assignment. Oh, and speaking of assignment, next week it's going to be next exercise is going to be different. What will happen is that an exercise will have two parts. Part one is a walkthrough. So it's just going to help you to get started. You have to do it before you move on to the second part. Second part is what you turn in for grading, all right? The first part is for you to learn the technique. You need to read everything in the Word file that is provided, and the script is given to you too, to make it easier for you, right? So you're going to run this, you're going to make sure that you understand. If not, you need to post questions, right? Make sure you understand it. Another thing I need to warn you about it, if I tell you that exercise approximately takes 5 hours to complete, it does not mean that you can start at 7 p.m. on Tuesday night and hope to be done by midnight when the exercise is due. That's not how it works. This is the time that expected to spend during the week. It's not the time that you can sit down ahead of due date and get it done. No, that's not how it works. Just remember it. It's a time that you need to spend during the week, not just in one sitting, okay? And to get those estimates, we did a little, we surveyed people who received high B in the course. It took, this is how much time it took them, but it's just an hour. It could take you less time or it can take you more time. But this is just an estimate, okay? If you're spending 50 hours instead of 5, then you might be doing something wrong. Perhaps maybe you did not do the part 1, which you have to do before you start part 2, right? Something like that. So questions. Guys, I want to see questions here. Please don't be shy. Okay, so finally we have something in the chat. So when importing a data file, you need to use as is files. So, yes, you do. You need to use this, okay. In the last version, it was not, no. In the last version, it was not used. No, it was not. But how did I find out? Let me tell you this. I installed version 4. I'll be very honest with you. I installed version 4. And then when I prepared for this session, what I did was I tried to run the code, right? And this is what I did. I had this here, and I ran this, right? I ran this. I removed this here, right? Okay, this is what I did here. I did this, but then When I got down to this in here, when I got down to the summary comments, I saw a problem. First of all, see this salary, why is it a character? See this? It's not that what I want. I want it to be factor. See this? And then also, when I got to this comment, oh, this is what gave me the problem. It did not work. See this? It returns null because this is for the factor variable. So then I said, wait a minute, what's wrong? Is something wrong with my data? No. So this is what I did. I did this. I figured it out. I did this. I ran the help command and I typed this read.csv. I did this. And then I looked at the help in here. And I found that this is what you need to do. You have to add this parameter right now. And it did it. See this? This one, as is. This is controlled the conversion of the character variables. And basically what happened was starting in the last version, in the last R version, it was taking the string as factors. It was converting them to factors by default. It no longer happens in this version. Okay, it no longer happens. Well, there is another parameter called this, string as factors. Well, it's something similar to as is, okay? But sometimes you want to be careful because you might have the text field that has to be actually stay as text, right? Like if you're gonna do one of your assignments, we'll be working with text, right? So you want to be careful with this too. As is did it, okay? Because in this R release, things work different. It's no longer taking the strings and converts it to the factor. So if you do it like this, like you did before, you would need to run the command to convert the string to a factor. You would need to run factor command. That's an option too. You're creating yourself extra pre-processing. Like I ran the factor command to on the left variable, right? I did that. You would need to run a factor command on this department and the salary. That's one way. But yes, this is new in this version in 4, and I found it out as I was preparing for this session. I always rerun the code to make sure there are no surprises because we don't want a surprise at the demo, right? Well, things happen, but you know, things happen. All right, and then there are going to be changes to all of the code files in assignments. But if you look at the code from the recordings, right? You're gonna do in week 3, I think, 4, 5. Yes, there will be recordings of the demos from last semesters. You would need to make that edit to that command where you're reading a file. You would need to set as is equals false. Yeah, this is new in this version. Yes. Well, what you also could do is there is a page that shows the changes for each version. When you go to the page to install R, there is a link where you can click on, and it's going to give you the delta for this version. It's going to give you some known changes. Again, but not all changes are known. We discover things like whatever you see in there is only for the pre-installed stuff, right? You still want to make sure that the packages you use are going to be compatible with this. So yeah, it's a lot of testing. Before each semester, all code is tested. Yeah, because R is evolving, remember that. So that's one thing, it evolves. Every minute as we speak, there could be new package. And when you get advanced, very advanced, you might be start writing your own packages, who knows, you know, yeah. So I hope I covered the question. It was a very good question, I liked it. All right. So let's see more. I want to see more questions. But yes, this is new in version 4. The latest one we had 3.6.3. Yeah. And version 4 came in April. So unless you used R in early May, then you probably used 4. Yeah. So Well, see, like I have to install the latest because this is what you'll be installing. You're gonna go and install the latest, so we need to use the same. Yes. So let's see. Do we have more questions? Let me see. And here, what you are using, this is a desktop R version. There is also server R. This is what you're gonna see in the second part of the 650. You're gonna use the server version of R to read data from the database and do analysis. So it's a lot of fun. All right. So you could basically see this. You can establish connections. You can connect to the database, and you can use a query to pull the data from the database inside the connection object and do that. But for the purpose of this class, you're just doing the CSV files for now. Okay? You're gonna be reading CSV files for this class. Okay? But I just told you something to look forward to do. Okay? So let's see, more questions, guys. So if there are no more questions, then I'm going to stop the recording. And what's gonna happen is this. I'm gonna give your professors the link to the recording, and I'm gonna give your professors all these files, the slides and the script and the data set. So that way, when you are watching this, you can follow along if you want to. But to follow along, you're gonna need to create the folder on a C drive called datasets, exactly the same spelling. And you need to copy this file into that folder, datasets, okay? All right, so going once, going twice, no questions. So I'm gonna do this. I'm gonna stop the recording.